No, I'm not starting over. Sorry, virtual students. We're on number 16 on 8.1, which would be the back side, but you don't have a paper copy, so I guess it wouldn't be. And we talked about sigma notation, which is right up here. And we are all part of the sigma fraternity or sorority. All right, if we had this sequence, 4, 8, 12, 16, 20, how would we write a rule for this? What would it be? A sub n equals 4 plus n minus 1. What's our common difference? 4. Good. Now, if we were to write this in simplest form, we would distribute the 4. So a sub n would equal 4n. We'd have a negative 4 and a positive 4, so those would cancel out. And we would just have a sub n equals 4n. Correct?
That's correct.
Now, in number 16, the directions say, write the series using summation. So we want it to be looking like this. All we need to do, put our summation symbol. Now, we are starting at, and I'll just use I equals 1, right? We have our first term right here. And then how many terms are we adding together? 5. So we are starting at I equals 1, and we are adding the first 5 terms. Because that's the term we are starting at. We are starting at the first term.
Oh, so that's like a sub 1.
Exactly. Yep.
Can you just rewind that kind of? Wait, so the 5 and the 4, can you explain that?
So when we look at a series, we are adding together a sequence. We're adding together the sequence 4, 8, 12, 16, 20, right? That's what we see there in number 16. If we wanted to write that using sigma notation or write that using summation notation, write it in this type of form, we first would write our rule, just like it was a sequence, like what we did yesterday and started out today, like. And then we would take our rule, and that would be what's in front of our sigma. Now, here is our starting term, what we're starting at. We're starting at I equals 1. And up here we have 5 terms, right? We're ending at 5. Exactly.
So we have to like do what we did yesterday, like do all that.
Yeah, there'd be an instance where we would start at like I equals 2 or
If they just list out the series like this, or then no, you would start at 1. But there will be examples. Well, we'll get to that in a second. Yes, Aiden.
So 2, like 4 would be how much is going up by, right?
Exactly. Yep. This would technically that's our common difference. Yes, we're going from 1 to 5. Mm-hmm. Now, if we sort of double check it, if we plug 1 in, we get 4, plus we plug 2 in, we get 8, we plug 3 in, 12, 4, and 5. That's what we started with, right? And that's what this represents, of plugging each number in from 1 to 5 and adding them together. Do we see that? Another way you'll see it written is 4 times 1 plus 4 times 2 plus 4 times 3 and up to 4 times 5. This would be our summation notation all the way written out like that. Yep, pretty cool word. I will do number 17 also, and then you guys can work on 18 and 19. Am I good to erase that?
Oh, good, great, wonderful.
All right. 17. If first we are writing our sequence, our starting term is 3. What is our common difference?
6, 3, 6.
we distribute the 6, we have 6n minus 3 if we simplify all of it. Now, we're going from, this time I'll use k. We're starting with k equals 1. How many terms are there? There's 5 again? Sweet.
There's 5.
I just decided to use k, just to show you that it doesn't make a difference.
Oh, so the one in the middle is what a n equals.
Right here?
No.
Where?
The one in the parentheses.
Here?
Yeah, so
Yep.
that's just okay. Got it. So it'd be easier to solve it the other way first.
To write
To write
a
all
rule
that out,
first,
yeah.
yes. Writing a rule first will be the way to go. Go ahead and work on number 18 and 19. Probably give about 2 minutes to work on those.
Yeah.
Oh,
Would this be this?
Yeah, it would be. Be careful, I think both of them. We have the dot, 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 so this is not a finite series. Yeah, you get to write the infinite. You get 2 really cool symbols around. Big bug here.
Yeah, it's that context, but it's easier to sub.
Good job, Grace. So proud.
Who's your dad? Literally, look, Zach Brown Band.
Wow. If we were, never mind.
who says this?
Zach Brown Band. He does not believe in me.
Hugh Jackman.
Well, this version is Zach Brown.
Oh, well, usually it's
Yes. But I think this one's.
No.
You guys doing okay?
I don't even like Zach Brown Band for the real deal.
What? What?
Get it?
Don't even
This
act like
is the
you
kind
know.
of stuff that we need more of.
I thought the rationals packet was pretty good. I thought it was kind of fun. Also, most of the problems on the test were in your packet.
Yeah, I know.
Yeah,
I didn't know that.
I found
all of them except 2.
Yeah. Yeah. Next year, they will not be using the packet on the test. That's for sure. What, Smitty? Okay.
Equal rights, equal fight. Yeah.
All right. Sounds like we're done.
No, I stopped it.
So let's look at number 22. Oh, what? No, I need to do one more of your homework problems for you. Not right now. Everything you need is on the board. All right, let's look at number 22. Look at number 22. It's up on the board. So, if we, this time they give us the equation and they say find the sum. So we have the sum of 3i from I equals 1 to 4. So that means we need to do 3 times 1 plus 3 times 2 plus 3 times 3 plus 3 times 4. So that would be 3 plus 6 plus 9 plus 12. 9 plus 9 is 18. 30. I have a couple blank faces.
I understand that. I follow.
We're good? You were one of the blank faces there, Maddie, so I'm good. I'm glad you got it. Yep. Rhea, good? Great. Gabby, we okay? Aaron? All right. Emma Tusky? You missed yesterday. Are you doing okay? All right. You probably watched the video yesterday.
I did.
Yeah. Again, good. Go ahead and do number 23.
Whoa.
I hope you're good at multiplying and adding, because otherwise that's going to take a while. Yeah. No, that's what your brain is for, Cole. I'll show you what the calculator is for in a second. Yes.
So if we're at 24, since we start at 0, is the first term 0?
Shoot.
So put 0 in.
Wait, the first term is 0?
Yes, we're starting for number 24. Yep, we start at 0, so we put 0 in first.
Oh.
I can't wait for this to get really hard to where I don't know how to. I'm just.
I think we're going to be okay for this first little bit. We have look, we have today, hopefully we're going to introduce geometric series and sequences. Tomorrow we'll finish that up. On Monday and Tuesday we'll do 8-4 and 8-5, and then we'll test review, test Thursday. So there's not a whole lot more to this chapter.
Whoa.
All right, let's look at number. How about 20? Sure, you want to look at 26? Okay, let's look at number 26. Everyone, pick up your calculator, please. Yep. I need you to hit math. Scroll down until 0, or just hit math 0, or you can scroll down. And then look what appears on your screen. If we're doing number 26, we would plug in, and the variable doesn't matter, right? Just x equals, we're starting at 1. We're going until 6, and we have x squared minus 3. And then hit enter,
What?
and there's your answer.
Thank you.
I was doing the wrong one.
I had to make you do.
Now on the test, we're gonna have a no calculation portion.
That's what I'm
We can't
saying.
do that.
So what are you going to say?
Yeah, there's a decent chance. You need to know what it means what the summation means, that we are adding these together.
93?
If there's a no calculator portion, it would have a problem like this. That's pretty simple, and not very many terms.
But nothing like 26 or
Right, nothing with fractions, or I'm not testing if you can add fractions.
Thank you.
Let's go.
Because that's what the calculator's for. Right. So go ahead, finish up that page, and then we're going to move on to 8.3.
I just put one of those summation things inside my line.
Yo.
You did?
I did too. What does it look like?
Well, you don't need to do that.
I know, I didn't need to.
Oh, on accident.
Negative 273.
Whoa, Mr. Lehman.
Yeah.
Number 27.
Number
I
27.
don't like it.
Plug in your calculator.
It gives me like a weird, it's like 5.4.
Yep.
Hey, no. You're not? I got
No, I should round on
7.3.
that one.
Does it say in the directions? Yeah, I rounded. I put 5.46. But you can round wherever.
Yeah, it's 25.93.
Yep.
You know how to do it without the calculator?
Also, while we were talking about the rationals packet, next year they will not be able to use a calculator on most of the packet.
Wait, what?
Because we need to practice our factoring a little more. We stink at factoring.
But that would be like unfair to them since we.
I'm good at factoring.
Well, at certain points I'll let them use a calculator. Like on the end, I'll teach them how to do it on the calculator.
Do you want
But
to be stored for?
yes. I have one more. We're learning a couple new things.
Wait, do we have another sheet to do that?
Well, we'll finish another sheet tomorrow, but I want to start it today because I think Yeah. By 3. It did. All right, finish up the one that you are on. Those shouldn't take long. I mean, that's button pushing. So those shouldn't take too long. That doesn't surprise me.
Yep.
All right, we're moving on. Did I give you 8.3 already?
No.
Oh.
Wait, Levi.
Brady, Tyler, my truck went, and I literally drove around inside the building and found him.
That's why I'm not getting it.
I did.
I did?
I would have said, you know what?
I'm not gonna
All right, we got one more, well, kind of one more thing to go over. Trey, if I hear one noise from that balloon, I'm taking it so quick.
Wait, Trey, can you put helium
Oh,
on
all
too?
right. That's distracting.
You should pop it.
I did not
Pop
make it.
it.
I will
Pop
after
it.
school. I'm popping all of them. No, not right now. The virtual students are going to worry that crazy stuff is happening. Okay, so look at your worksheet. Well, don't look at your worksheet yet. Look up here. So far, we've talked about arithmetic sequences, right? Where we're adding consistently. Now, on 8.1, there was one, number 4, was not arithmetic, but mostly we've talked about arithmetic sequences. What I want to introduce today, and we'll finish up tomorrow, is geometric sequences. So if you would have been in my Algebra 1 class last trimester, you would have seen this slide where we introduced geometric sequences.
That's easy.
That's probably true. That was actually kind of funny. The ratio between consecutive terms is the same with a geometric sequence. This ratio is now called the common ratio, which is kind of a lame name. But with an arithmetic sequence, we had a common difference, right, where we were adding or subtracting. Now we have a common ratio where we are either multiplying by a whole number. We don't say that we're dividing with these. Instead of dividing, we are multiplying by a fraction with these.
Why would you do that? I don't do that.
So if you put that the common difference is dividing by 5 or dividing by 7 or whatever, then that would not be correct. You should say multiplying by 1/7 or multiplying by 1/5. You will not get full credit.
Wait, what? So if you put multiplying by 5, then that's not right.
No, for this is correct. If you had a sequence that was going the other way,
Well, yeah, it's like number 1 on your packet. You're on paper. It's divided by 2.
oh, perfect, because I'll do your homework for you.
Yeah,
Number 1.
that's good.
I read 1 the first 4.
And I'm not going to write the rest of them, but each time we are dividing by 2. But if you put that our ratio is dividing by 2, I would say, what, Caleb? Wrong.
No, half credit.
Maybe quarter credit.
3/4.
It should be multiplying by a half.
Half credit.
Super funny. So, why don't you go ahead and do number 1, 2, 3, and 4. Good job.
Fine, you got it.
It's not.
It doesn't have to be.
You have to tell whether it is. Is it or not? Is it or not? Not all of them will be.
That is not one.
Good job, Trey.
Good.
I was guessing.
Wait for which one? Let me do my work.
Let him try it on his own first. What? No. No drugs.
Mine, which one is
No. We're putting him
That
Do it with Vanessa.
sounds like fun.
No.
You're endangering the environment.
About
I'm vaccinated.
10 more seconds to finish up 1 through 4. Thank you. Don't let it happen again.
Yeah. Oh my god, you should hear him every day in eighth class.
Well, that would be an appropriate setting to make chicken noises because you're an ape.
About 5 minutes. Yeah. First 5 minutes.
All right, we're ready to keep going. So, when we had our arithmetic sequences and we wanted to write an equation to find the nth term, we had a sub n equals a sub 1 plus n minus 1 times our common difference. Now, when we have a geometric sequence, this would be the equation we use to find the nth term. Again, we've got that nice space, we'll say background, because if you would have been in Algebra 1 with me last trimester, then you would have seen this equation already. So hopefully this seems semi-familiar. Now, what does, you guys tell me, what does R represent? What is that? That is our common ratio. Yep. And then N is still whatever position that term is. Can you guys just not be distracting for like 5 minutes? You're distracting me.
It's a very cool trick.
So, if we are looking at number 5, let me keep doing your homework for you.
Yay.
The first term is -5. And each term is 3 times the previous. Write an equation. Well, let's see. What did we just talk about? A sub n equals a sub 1 times r to the n minus 1. There's our equation. Now, what some people think is, oh, these are being multiplied. We can simplify this to this.
No.
No. No.
No.
Do not do that. Leave it like this.
No.
We could mix in some logs here if we wanted to.
No, I forgot all of that already.
Did you ever know any of that?
No.
Okay.
Like maybe 1 or 2.
All right. Yeah. Yep. Go ahead and do letter B. What do you do?
What do you mean? This is super.
Oh, you can do number 6, 7, 8, and 9 also. So why don't you finish that page? You can't do anything to it. What do you mean? Leave what? This? Yeah, this is good. This is good. That's the answer. That's 5A.
Oh.
I told you I'm doing your homework for you. I'll give you the answer right there. Is somebody watching Netflix? Or what am I hearing right now?
Nothing.
I don't. Yeah, I have my phone up here. I'm watching it.
I don't think anyone would do it.
Oh, that's in the hallway. Okay.
You're too strict with
Yeah.
No, I don't take your phones enough.
Yeah, you
That's
do.
true.
Also true.
Oh, we might finish front and back today, which means I can do a small big ideas assignment.
No.
Oh.
2 lessons in 1 day.
We kind of did 3 today because we had to clean up yesterday's, and then we had to do 8-1, and then we're gonna finish 8-3 today. That's insane.
That is way too many lessons. That's too productive.
No, there's one type of problem. We're not getting to summations with these today, so we're gonna have to look at our summations tomorrow a little bit.
Scroll back up to
Yeah, to the equation
the
right there. And number 6 through number 9, well, and in number 5, when it says write a rule, that would be just like this, just like what we did in 5A.
If your rate is times 2, how do you
If your rate is what?
like times 2?
Then For which one, Trey?
Oh, okay, never mind. I'm good. I'm
For number 6?
good. Three.
Why did they do that?
Make sure you find a sub 7. So plug 7 in for n. Now the correct,
Oh, I get it.
to find a sub 7, look, the correct way to write our answer is we would say a sub 7 equals, I don't know what it is, 2 to the 6th power would be 32 or 64. 2, 4, 8, 16, 32, 64. 64 times 3
192.
would be 192. So this would be the two correct things that I should see in number 6. There's your equation. A sub 7 equals 192. Can you guys see that back there? Question?
Yeah, for number 9, so it's dividing by 1.5. And you know how you said that like don't put divided by put in a fraction?
Right.
Well, how do you put that fraction in fraction?
So
That makes sense.
Yes.
you said it's 1.5.
Yeah.
So we would have, yes, you would, Ryan. A sub n equals 36 3/2 to the n minus 1. We probably can put parentheses around here if we want to be really safe. But
Whoa!
or if you put 1.5 instead of 3/2.
Which one?
Like that would be okay too.
Oh, I think that's right.
What is
That's
that?
not right.
What's not right?
That's
Is it not being, oh,
down,
it's
down.
not, it's going down.
Should be a negative.
Sorry, did I not totally understand what? Okay, my fault.
But yeah,
What-
because you know how you like it was going down divided by 6, put it in 1/2.
Correct.
But
But
it's already
it's already 1.5. It looks like we are going down by 0.25. I did not find.
So it's 210.
Oh, it's going down by 2/3, isn't it?
Yeah, that's I had 3/4.
It's going down by 2/3. All right, backside. Oh my goodness. I know we're going crazy.
We're getting so much done today.
We are. We're making up for how.
It's 256 over 9.
Never mind.
Oh, what is it actually?
Say it.
How'd you get that?
You can math enter it on your calculator.
Mhm. What'd you do?
What'd you get for 8 sub 7?
I didn't plug that in. Yeah, I didn't plug that in.
It's 256 over 81.
It could be. Yeah, I haven't been able to make a key yet. Let's look at number 10. We need to write a rule for the nth term and then the first 6. We know it has to be in this form, right? And in this case, for number 10, they give us that a sub 3 equals 9. So you guys tell me some things that we're going to plug in. What can we fill in? The 9. Where's that going? Which one?
We can fill in the rate and that's it.
Not necessarily. What can we fill in? When we look at number 9, they give us some information. Here's our equation, the form it needs to be in. What can we start to fill in? With, for number 10?
Yeah.
Jose, you need to get to class.
I want lunch.
Oh, why didn't you tell me that the first time?
I was in class. Jesus.
Hey,
Nemer,
watch it.
how's it going, buddy?
Get out of here. All right. Hey, we got one more problem we got to finish up. You get out of here, focus on lunch. Is it Josue? Oh, no one told me that.
All right. We know what the rate is. It's 3.
The rate is 3. What else do we know? We don't know a sub 1.
8 is 9.
Yeah, what term is this? We have a sub 3 equals 9. So what term did it give us? The third term.
So put 3 up there. Whoa. Hey.
What do you mean? This is exactly what we did with the other equations.
What are we doing?
This is completely new.
Never seen
Never
before.
seen.
Whoa, ace of 1 is 1.
Ace of 1 is 1? No, but here's wait.
Now we don't need to write that 1 there for ace of 1, but just so we're all on the same page. How what?
Let's just be done for today. We got 5 minutes.
5 minutes phone time.
It's fun.
Phone time.
I think we really
Yeah.
done this well.
We did this.
Good job.
today.
Today was much better. Tomorrow we will finish this, and then I'll have a very small assignment that has to do with summations of geometric sequences.
Yes. Alright.
What? They're working till the bell, finishing that worksheet.
That's fine. Oh, sorry.
That was a.
Caleb, you're not. Oh, Caleb.
7th grade going into 8th grade summer.
What'd I do?
You were being nice.
Yeah, you're being a nice guy. Yeah, he was yelling.
Tomorrow we're just doing the summation stuff instead of the You already know this.
Scary. Anyway, you look at my hands. That was kind of scary.
Hey, did you chase Smash on purpose today?
Me? No.
Oh, I'm still recording.
Guess who's official midfielder?
One of these days, I just want to.
I don't know.